So are we
Yeah.
technically like all on the spectrum? Or
A
is
lot
it
of
just
people say that.
Mhm.
I would say no. I
Mhm.
mean, I think certain things, right? Like OCD, for example. Like we're all on the spectrum of OCD, even
Mhm.
though it's not a spectrum technically. But I think that like I'm not autistic. I don't know anybody. Well, I do know a few people that are autistic, but I guess I feel that by saying everyone is somewhere on the spectrum is almost insulting to people who do have autism, because I think that a lot of the people who have autism are very proud of it and very, they kind of embody it, and which I think is awesome. And I guess I think the other thing about like the whole "are we all on the spectrum" thing is, like I said earlier, there's a social component of it, which I do think everyone lands somewhere on a social spectrum for
Sure.
sure.
Mhm.
But then there's also the repetitive behaviors, and the fact that those two things go together means that there's probably some sort of specific, like neurological system that is participates in the control of both of those things
Mhm.
that is somehow disrupted in autism.
Mhm.
And I would think that typically everyone's system, whatever system that is not disrupted. So
Okay, cool,
Yeah, man,
fair.
there you have
So
it.
you said
Yeah.
two parts, social and then the repetitive
repetitive
behaviors.
behavior.
Okay, why is the social, like why are people with these brain activities socially reserved? Like, or they're incapable or
Yeah.
find
So
struggles. Yeah. Mm-hmm.
that's one of the biggest
Mm-hmm.
remaining questions in autism research, essentially,
Mm-hmm.
is like, why? I mean, first off, what brain functions are important for sociability, and then why do those, which of those brain functions goes awry in autism, and why? um, there are a bunch of different brain areas that have been implicated in autism. The brain area that I study is the prefrontal cortex, which you may have heard of. It's kind of like right here, and it's super important for like anything that makes you human, kind of in a way, like any higher level thinking, sociability, these kind of advanced functions. But it also exists in other, in like mice and rats. It just may have different, may not have as strongly evolved functions. But in the prefrontal cortex, there is sort of a theory, and I guess this extends to other brain areas too, of excitation inhibition imbalance. So, like I said, you have all these cells, they interact with each other, they have all these synapses with one another. And those synapses can be either excitatory or inhibitory, in that they're either activating or shutting off the next cell in line. So, like, let's say the three of us are synapsing, right? We're three different cells, and I have a connection with both of you, and you both have a connection with each other and me. Let's say I'm an inhibitory neuron, so I only shut off you two. But let's say Ali, Los Angeles Ali, and let's say both of you guys are excitatory neurons, and that you
Mm-hmm.
both activate the other cells.
Mm-hmm.
So, okay, now let's say Ali Shammari, right?
That's me.
You are the cell that we're talking about in this case. And if I'm inhibiting you, if I'm shutting you off, and Ali is turning you on, then, which I'm sure he does all the time, then you're going to be about even, right? Like your net activity inhibition is going to be about even. But let's say Ali were to kind of like shut off and like not be active or not really do anything, and I'm just inhibiting you, then your activity is going to go from this like homeostatic level to too low, or vice versa. If just Ali stimulating you, then you're going to be too high. And so this general idea is that like due to some change or something causing it, there's a loss of excitatory transmission or inhibitory transmission, which leads to a general hypo or hyperactivity of the whole brain area. And either direction can affect the function in a negative way. So, and that's kind of what I study. So that's the one I'm most comfortable talking about.
And you can detect these things, right? Like,
oh yeah, for sure.
Like the parts of the brain that are so it's just not. It's not the neurons themselves aren't like sparking up in these areas, right? From what you're saying.
Yeah, I mean, what we do, literally,
Mhm.
like what I do, is something called electrophysiology, where we actually take these brains and we remove the brain. We have the brain, and we basically, this is going to sound really like gross, and probably some people are like, "Oh my god," but we slice the brain, and we preserve the
Make a
slices.
sandwich.
We preserve the
No,
slices.
see, now you made
it.
it disgusting.
I'm sorry.
I'm
Like
sorry,
what he said was normal, but
Yeah, it was fine.
sorry. Yeah, go ahead. I just had to remove the brain sandwich out of my head.
Yeah. So we have these slices and the cells are still alive. And then what we basically do is take this tiny little electrode and stick it onto the cell and record that cell's activity. And then we can like stimulate all sorts of things. Like we can stimulate the inhibitory connections or excitatory connections and sort of record what the end result is for that cell. And in doing this, we can sort of create how intact are the inhibitory and excitatory inputs. And we can sort of measure like that balance.
And is this the same thing for like the repetitive behaviors? It's like just the same idea kinda, or is that a different explanation?
So the repetitive behaviors are interesting because they probably don't have as much to do with the prefrontal cortex as sociability does. Sociability definitely is involved in PFC, or PFC is definitely involved in sociability, I should say. That's been shown over and over again. The repetitive behaviors are probably more so involving a structure called the striatum, which is involved in like movement initiation and like goal-oriented behavior. So there's, I guess, sort of a big question.
Can you pull it up, Ali? Sorry, I want to see what is the striatum. Yeah. Yeah.
Spelling, please.
Yeah. I love how Ali's sort of like the DJ, like, yeah, you can play that down. Look at that.
It's pretty much, that's pretty much what I do on the show. I just search stuff. I'm guessing this is it.
Yep. Yeah. So like you have, it's kind of like this big ball.
Which picture should I go for? The first, starting from like